In this series, what we are going to share with you is our insights built on our experiences working with enterprise customers on how they are adopting upcoming technologies to evolve their traditional setups. In every episode, we will be sharing experience of our journey with you all. So for past couple of years, we have been instrumental in building solution for our enterprise customers, and one of which has gained more momentum is logging solution. So most of the time we have seen our customers starting with basic logs, example Nginx or infra logs, and when they start seeing success, they start leveraging this platform for other enterprise logging system. So now suddenly what happens, not only the volume of data, but the expectation from this platform goes beyond reliability and scalability to much of how the resources can be optimized and how the dynamic scalability along with the portability of the workload can be achieved. So over past few months, we have been working with our customers on ground to design architectures which would be more scalable. And we thought that this is a time when we should leverage the capabilities of containers and container orchestration technologies. So today, what I'm going to share with you in this couple of maybe 4-5 minutes is how we were able to leverage container and container orchestration capabilities to scale our traditional setup for our enterprise customers. So on this slide, what you can see is a very traditional and typical way of setting up log aggregation architecture. Here, what we have done for our customer is we have ingested logs from various sources using the beats, file beat, metric beat, heartbeat, and these logs were ingested into Logstash where we created the filters, and from there it got ingested into the Elasticsearch, from where the customer intend to take this log further for visualization. Now what I'm going to share with you is a specific section of Kibana where we have leveraged the container capabilities, container and container orchestration capabilities to make it more scalable and portable. So if you'll see here in this architecture, what is happening is the way Kibana has been configured is in active passive mode. And why we have done this? To avoid a single point of failure at visualization end. But as I mentioned, slowly the load on the Elasticsearch with ingestion of logs are increasing, the data volume is increasing, the requirement is more and more in terms of building visualization and dashboard. So what does it mean is more Kibana resources need to be added. Now if we have to add in this architecture more Kibana resources, what it means is there will be passive nodes as well, which is not the right way to optimize the architecture. So we thought this is the right time to leverage the capability of containers to at least make that section more scalable. So if you'll see on this slide, what we intended to do is we containerized Kibana and we removed that passive node. Now once we have containerized this Kibana, what we are addressing is a single point of failure, because the moment this container fails, due to the container orchestration capability, a new container can be spawned up. And this addresses the single point of failure for Kibana. Now your new container has been spawned out and that is acting as your Kibana node. What it does provide is a dynamic scalability. So it's not only addressing a single point of failure, but it helps you in adding more Kibana containers as the workload increases. Now, when we have multiple Kibana nodes, which means like each node is acting as a master, so this becomes multi-master kind of cluster. But in this case, how we will address the high availability? Because if user has to connect to the Kibana, now they don't have a single virtual IP, which they would have in active passive cluster. So what we did, we introduced Nginx. Now Nginx is acting as a load balancer for the Kibana containers. But in this case, what happens if Nginx fails? That is again a single point of failure. Now instead of adding another node as a passive node for Nginx, we decided that we will containerize Nginx. And what we did is, you can see on the slide, we containerized Nginx. So if Nginx goes down, a new container can come up which can act as a load balancer. So overall, if you'll see on right hand side of this slide, the Kibana nodes and the Nginx as a load balancer are containerized, and what it is providing to the customer is scalability, not only scalability, dynamic scalability, ease of manageability, and very important is portability. Today they are on premises, tomorrow if they want to take this to cloud, for that matter of fact, any cloud service provider, because they are containerized, it becomes much portable to go on cloud. So this is one of our experience what we wanted to share only for how we leverage container and container orchestration for Kibana and Nginx section of this architecture. So guys, if you see today container orchestration and scalable deployment are areas which all the enterprise customers are exploring for their on-site deployment, and we would be working very closely with them and would be sharing some more real-time experiences in our next episode. So guys, watch out for how we were able to containerize Logstash in our next episode.